Hello everyone, welcome to the second session of GDSC Banasthali Vidyapith's GitHub Bootcamp. This is Sakshi Goyal, team member of GDSC Banasthali Vidyapith. First of all, thank you everyone for joining this session. If this is your first time attending the GDSC event, then let me guide you through GDSC. Google Developer Student Clubs are college communities which are led and run by college students. We work collaboratively to build solutions for real world problems, and GDSC Banasthali Vidyapith is one among them. Moving further, we have the timeline for the upcoming sessions. We have a whole bunch of sessions till 26th September 2021, where we will be guiding you through GitHub and open source. Next, we have the learning objectives for today's session. We will learn about basic terminologies used in Git, frequently used Git commands, hands-on demonstration of all these commands, and also how to undo changes using Git. So without much ado, let's start with today's session.
Now, let us first learn some basic commands which will help us to manipulate the folder structure easily from the Git Bash itself. So the first command is the ls command. The ls command is used to list files. It lists all the files in the current directory except for the hidden files. The second is the mkdir, which means make directory. It creates a directory or a subdirectory. Third is the touch command. The touch command is the easiest way to create new empty files. We'll use these commands in the hands-on demonstration. Next, we move on to initializing a Git repository. So after you install Git, you can initialize it onto a project to create a new Git repo. So what is a Git repository? A Git repository is the .git folder inside a project. This repository or this .git folder tracks all the changes made to files in your project, building a history over time. So the command to initialize a Git repository is git init. So let's see its demonstration. So as you can see, I'm inside a folder named Tuto, which is on desktop. So now let's create a project or a folder whose history we want to save using Git. As we learned, the command for making a directory is mkdir. So I'll right click here and git bash here. So that git bash will automatically take the specified path. Now type mkdir and the name of the folder or the project, let's say demo. So as you can see, a new folder named demo has been created and we want to initialize it as a Git repository so that Git tracks the changes that we do. So first move inside this folder using the cd command, which is change directory. So type cd, the name of the folder, which is demo. So now as you can see, I'm inside the demo folder and now we can initialize it as a Git repository using the command git init. So as you can see, an empty Git repository has been initialized. So as I told you, there is a Git folder initialized inside the folder when we execute git init. So if we execute the ls or the list command, we don't see any folder, but if we execute ls -a, which basically means show all the hidden files as well as the normal files. So you can see there's a .git folder. So any file or folder which starts with dot is hidden. Now our Git repository is initialized and all changes will be saved in this .git folder as a history. Now let's create a readme file inside the demo repository. We have already seen the command touch for it. So now type touch readme.md. So a file is created and now I'll open it in my code editor VS Code. So I'll use the command code space dot for it. So let's write some simple text, hello world, and save it. So now there's a change in our project, but how do we see it? So now let's move to the next command, which is git status. The git status command displays the state of the project. So it lists all the files that have to be committed. So now if we do git status, we see there's a file which is currently not in the history of the project. So it is showing in red. Now we want to add these changes to the history. So in Git, before making the final changes, we need to explicitly tell Git which files or which changes we want to include. So a file is not automatically included in the commit just because it was changed. So first we need to add them to the staging area, for which we have the command git add. The git add command adds a file to the staging area. What is a staging area? A staging area contains a list of all the files you want to include in the next commit. So now let's do git add and the name of the file, which is readme.md. So now it's added to the staging area. So now if we do git status, we have the changes which are to be committed in green. So now let's see how to commit the changes, or in other words, take a snapshot of the project's currently staged changes. So for that we have the command git commit. So the git commit creates a commit which is like a snapshot of your repository. The commit command is used to save your changes to the local repository. So now if we write git commit and -m, which is basically for a message, I'll give my first commit. So now we see the changes are committed. Now if we see status, git status, there's nothing to commit and the working tree is clean. That means there is nothing to commit. So now, for example, we have multiple files which have been changed, then it will be very difficult to commit each of them one by one. So let's learn another way in which we can add one or more files in a single time. So now let's first create another file, readme2.md, using the command touch readme2.md. Now let's put some text in the readme2.md, simple text, hello world again, and save it. And also let's make some changes in the previous file, which is readme file. So now if we check git status, so we have two files which are modified in red. One is untracked and another is modified. So now if we want to add both of these files in a single command, then we have git add and space dot, which basically means add all the files which are changed. So now if we check the Git status, both the files have been added to the staging area. So we can again do git commit to commit the changes, the git commit message, my second commit, or anything you like. So the changes have been committed. If we do git status again, the working tree is clean and we have nothing to commit. So that's all from my side. Over to you, Anisha.
Thank you so much, Sakshi. Good evening, everyone. I'm Vanisha Vesh, a technical team member at GDSC Banasthali Vidyapith. Up till now in the session, we've learned about the Git workflow. The basic Git workflow goes something like this. You modify files in your working directory, you stage the files, adding snapshots of them to your staging area. You do a commit, which takes the file as they are in the staging area and store that snapshot permanently to your Git directory.
Now I'll be discussing few more commands that will be helpful in staging area. So the first command is git log. The git log command shows a list of all the commits made to a repository. You can see the hash of each git commit, the message associated with each commit, and the more metadata. This command is useful for displaying the history of a repository. Let's walk through an example to illustrate how the git log command works. We have been working on a repository called demo in this session. Now we want to see a list of all the commits we have pushed to a repository. To do so, we can use the command git log. Now this is the output that the command gives. Let's break the output step by step. The first line here is a series of alphanumeric characters. This is the secure hash algorithm, SHA, hash for the commit, which is used to uniquely identify each commit in the repository. The next line consists of the author of the commit as well as its email ID. The third line consists of the date and time associated with this commit. And the last line consists of the message which is associated with the commit. All this data gives us useful information about the commits in a repository. Now the next command is git show. It's basically like a git log but with more detail. Git show is a command line utility that is used to view expanded details on Git objects such as blobs, trees, tags, and commits. Git show has specific behavior per object type. Let's see an example. Let's modify the readme.2.md file. I'll write here hello world again and I'll save it. Check the status of our repository and I find that I've modified the readme2.md file. I'll add it to my staging area and then I'll commit. Right, now the commit has been made, which means that this modification has been transferred to the local area. Now let's see the git status again. It tells me there is nothing to commit. Now let's run the command git show. This tells me basically what it gives me, that for commit it shows the log message and the textual difference between the two files, which is hello world again. So I have appended this, I have actually imported this text in my readme2.md file. So this is telling me the difference between the two files. Right, now the third command is express commit. Now what it states is when multiple modified files are to be committed at a time. Now the keyword is modified files, right? Instead of executing add command, which is the git add dot command, and we follow it by the commit command, which is git commit -m, we can directly use the above command, which is called express commit. Let's see how this command works. So according to the definition, we get to know that we don't need to traverse through the working area, then the staging area, and then to the local area when we modify an already committed file. We will commit directly and efficiently. Let's make a change in the file again. Let's save it. Go to Git Bash, write git status. We get to know that the readme2.md file has again been modified. Now let's use the git express commit command. Git commit -am express commit. Now what does this -a, which is again addition the letter A, what does it mean? It basically means that all the files that have been modified in this repository will be added to the local repository, which means that it will be committed without going through the staging area, right? So let's run this command, and we are seeing that one file has been changed and 3 insertions have been made. Let's check the git status again. We see that we have no changes are yet to be committed. So which means that the file that I've modified didn't have to go all the way through the staging area by writing the commands git add and the git status. Instead, I used a single command, which is git commit -am express commit. Right now, what if I include a third file in my directory, which is touch readme3.md? So I include this file in my repository. Now what if I run the same command, which is the express commit command, because according to this, commit is going to commit any changes in my file, in my directory, right? Now what we see is it is throwing an error. It is saying that this is an untracked file. So what happens is that the prerequisite for this command to work is that the file that we have added or modified, it should have gone through the staging area at least once in the entire process, which means that readme3.md file has to be admitted to the staging area using the git add dot command and then the git commit -m fourth, which is any message that you'd like to import, and then only we can use the express commit command. So again, if I make any changes in my readme3.md file, we'll see, suppose I write checking the command, I'll save it. Here I'll check the git status, and it is telling me that readme3.md file has been modified. Now using the express commit command, now the file has been committed successfully. So the prerequisite for this command to work is that the file that have been modified should at least work through the staging area, should at least traverse through the staging area once in its entire process. The next command is git reset. As the name suggests, reset stands for undoing changes. The git reset command is used to reset the changes. It acts as a time machine for Git. You can jump up and forth between the various commits. It has 3 core forms of invocation. Each of these reset variations affects specific trees that Git uses to handle your file in its content. So what it is saying is, if I want to go back to my previous version of code, or for example I've made some updates or modifications in my code and I want to undo that, especially if I close my editor, this is the command for it, right? So firstly I have to check what files I have modified. So supposedly I again modify my file saying checking the reset command, right? I'll save it. I'll check what file have I modified, and then I will add this file to the staging area. Again, I'll check if the file has been added to my staging area. Yes, it has been added. Now what it is saying is git restore --stage. This command can be used to unstage. We'll use the git reset command. Let's run this command, git reset, and in capitals we'll write the term head. Now the term head, it refers to the current commit that we are viewing. So we are viewing this commit that we are making for the readme3.md file. So I'll run this command. and my readme3.md file has been unstaged, which means that it is no longer that I need to first send it to my staging area for it to run, right? Now what if I want to delete the modified content, right? Like what if I want to delete this checking the reset command line? So for this the command is git checkout hyphen hyphen and the name of the file where I made a change and I want to delete it. Now concentrate on this term, right, on this line. When I run this command, this line will get deleted. Let's see. The command has deleted and the readme3.md file has turned back to its previous version. So the git checkout file command is similar to using the git reset with a file path, as we've seen that we had to write the name of the file from which we wanted the content to be deleted. Now except it updates the working directory instead of the stage. This removes all of the subsequent changes to the file.
First open source project, Code Crossroad, is live on GitHub. You can visit our GitHub repository and contribute to this project to be a featured contributor. Moving forward, here's a glimpse of GDSC's 30 Days of Cloud. The registration for the same has begun. All the swags present on the screen can be yours. Don't forget to register for the same. We would like to thank all the attendees for joining on today's session. Stay tuned in all our social media handles for more updates.